The Orion Machinery Company Limited is located in Nagano Prefecture in central Japan, commanding a fine view of the Japan Alps. It was founded in 1946 and is now the parent company of the Orion Group with 30 affiliated companies. It has a staff of 650 and capital of 380 million yen. It produces a wide variety of products, including environmental equipment, vacuum pumps, freezing equipment, and other industrial machines, making full use of its advanced technologies. A main feature of this company is the production of many different products in small quantities. In recent years, there has been a big increase in the number of orders for individual specialized products, and also many requests for reductions in delivery time. In 1983, the company decided to introduce a policy of reducing the pre-delivery time by 50%. In other words, they wanted to improve their just-in-time methods. But just-in-time was not really feasible with such long setup times in the plant. It was clear that improvements in setup operations were essential in many sections, including the sheet metal, mechanical equipment, and assembly plants. In this volume, we're going to take a close look at the methods employed to work towards zero setup operations for NC milling machines and in the sheet metal plant. The challenge of this plant was how to more effectively respond to the diversified needs of customers and more fully implement just-in-time methods. Two main aims were obvious to everyone: increased standardization and zero setup operations. The first step was to organize a setup operations research team to consolidate needs and ideals. Now let's take a look at the system worked out by one of these teams in the production department, as it aimed for zero setup operations for NC milling machines. These machines are used for cutting grooves, one of the processes on a vacuum pump processing line. This plant produces 39 basic models of pump, but there are around 800 model variations. Total production is 43,000 units per year. The lot number varies considerably, between 5 and 100, involving a terrific amount of time for setup operations. Before improvement, the number of setups per day averaged 7. Here are the major parts of a vacuum pump. A total of 9 machines are used to process the central rotor. Zero setup operation improvements had already been made to 8 of these, but not to the NC milling machine.
Our calculations showed that the NC milling machine setup operations took 20 minutes on average. This meant that the total lost time every year was something like 70 complete days. We had to find a way to increase production while dealing with many small lot numbers. Our first aim was to get the setup operations time down from 20 minutes to less than 10.
The team began by analyzing the setup operations to find out what types of waste existed and how they could be eliminated. They had the interesting idea of recording an actual setup operation using a home video camera operated by one of the team members. They then divided up into several groups to watch the video very carefully several times. They analyzed and timed different parts of the setup operations and searched for evidence of waste. They were then in a position to create a detailed work analysis sheet, which clearly indicated areas ripe for improvement. But there is one type of waste not apparent on an operations analysis sheet: waste arising from unnecessary motion of the operators. To analyze this type of waste, a diagram was drawn up showing the movement of the operator around the milling machine. All the waste points identified were divided into three broad categories. 1. Unnecessary preparation. 2. Unnecessary exchange. And 3. Unnecessary adjustment. The next step was to begin developing ideas for possible improvements. After wide-ranging discussions of many ideas, they were finally able to create an improvement implementation planning sheet. The improvements were divided into three categories, depending on the time and cost involved. Small improvements, which cost almost nothing. Medium improvements, which cost a little more. And major improvements, which cost a lot and also take much longer to implement. Before examining examples of waste elimination for the NC milling machine, let's just take a look at the company's list of 8 basic principles for waste elimination procedures. Prepare in advance as much as possible. By all means, move your hands, but try to avoid having to move your feet. If possible, never remove bolts. If you must remove a bolt, always remove it completely. Don't change the standards for dies and jigs. Adjustment is basically waste. If you must adjust, only move small things on the periphery. Change from reading scales to using block gauges. Choosing a gauge is okay, but adjustment is wasteful. Set up stoppers and guides wherever you can. Now let's have a look at some of the actual improvement points and how these 8 principles apply to them. First, 2 examples of elimination of unnecessary preparation.
Before improvement, it took us a long time to get all the parts together ready for setup. Our improvement was to install an exclusive table just for this machine. We've saved a lot of time as a result. Another point is that we used to have to stop the machine to lubricate the arbor. The improvement here was to install an oiler to do the lubrication while the machine is in operation.
Next, 2 examples of elimination of unnecessary exchanges.
Now I'd like to show you an example of eliminating exchange waste. We used to exchange the index center by removing these 3 bolts. However, by adding pear-shaped holes to the center, exchange became much simpler and quicker. To open or secure the doors, we used to have to use 2 bolts, which had to be removed completely. We got rid of this waste by substituting a one-touch clamp like this.
And now 2 examples of eliminating unnecessary adjustments.
Before improvement, when we wanted to exchange the holder, we had to remove the whole thing, including the V-block, by removing these 4 hexagonal bolts. After improvement, we made it possible to leave the holder firmly fixed and simply change the V-block, which saves a lot of time and effort. In the case of adjusting vices, we had to move the vise after fixing the metal fittings on the tailstock. After improvement, we use spacers specially designed for each machine, so the vice screw movement has become minimal. Just by implementing small improvements, we reduced setup time from 20 minutes right down to 9.5 minutes, very close to our basic target. When we got going on medium and major improvements, we reduced it further to 5.5 minutes. There are still many more improvements we can make, so right now we're aiming at getting down to 3 minutes.
Now we'll take a look at the steps taken in the sheet metal plant to introduce a flexible manufacturing system, or FMS, using automated setup operations. FMS means the ability for one processing machine to switch products simply. Zero setup operations are essential for the introduction of FMS. We'll look at exactly what was involved with Mr. Kobayashi's setup operations team. The first step was to conduct PQ analysis to get a full understanding of the situation at the job site. The results indicated there were mostly small lot numbers involved, with 50 types of A items and 1,250 types of B items. They then inspected the job site to see how to go about waste elimination. Here are the different types of waste they discovered. Piling up of half-completed work. Waiting time waste. Setup operations waste. Transporting waste. Defects and reprocessing waste. Yield waste. Lack of size standardization. Their conclusion was that the biggest cause of waste was in fact lack of standardization for parts. They decided to implement the following improvements, taking standardization as a takeoff point. Part standardization, which involved analyzing the parts used in each product to find common points. Die standardization, to reduce the number of types of die from 200 down to 48 to match the number of turret punching press stations. Blueprint standardization, to redraw the plans for parts according to the reduction in the number of die types. Zero setup operations for NTC. This is to achieve a 100% rate of operation of FMS with zero setup operations. Creation of a U-line for the assembly process in order to operate FMS efficiently. Those are the items they decided to improve. The first procedure was to create basic ideas for a standardization scheme in order to reduce the number of types of die to 48. And to determine whether the basic ideas would work in practice or not, it was necessary to go to the job site and examine each part in terms of length, depth, size, and so on. After this checking, the workable ideas for standardization were tabulated like this. Here is an example of processing after implementing standardization. The arc of the circumference becomes just one type, 5R, and for opening large holes, a 20 pi nibbling process. The next procedure was to begin standardizing the dies based on the part standardization. The dies in use up to now were divided into types A and B. It became clear that the majority of dies were based on the A pattern, and that the likelihood of being able to reduce the 200 types down to just 48 was very strong. The ideas for the standardization of dies were then tabulated like this. The reduction in the number of dies naturally affected the design of parts. More job site inspection was necessary to check all the parts and think about how to redesign them. The resulting standardization blueprint was job site oriented. As we have seen, the result of all this was to produce plans for standardization of parts, dies and blueprints. Once the standardization procedures had been finalized, it was possible to launch FMS introduction. Because of the die standardization, zero setup had been realized. In other words, it was no longer necessary to change the die each time. As a result of the realization of zero setup, they could see the possibility of a total flow between the automated warehouse, FMS, and the assembly process. However, the assembly process was in a straight line placement without a continuous flow. So the next target was therefore to create a U-line for assembly. Through observation of the job site procedures, it became clear that delivery delays were being caused by defective products and readjustments made necessary by having too many works in process. One man, one machine production meant a lot of unnecessary waiting time. The first step was to attempt to get rid of the goods in process waste by creating a U-line so that there was an uninterrupted flow of processing. Now let's look at how the setup research team proceeded to improve the lines. The team analysed the processing route taken by representative parts from the PQ analysis. Here are the results. Based on this analysis, families were created and 3 line configurations emerged. They decided to try these out as one-item flow production. Time observation was employed to try and determine just how many operators were required for each line. Calculations were made for the RSK cabinet line, a representative F1 air conditioner. The result was 1.2 persons. But the question remained how to reduce that 1.2 figure to exactly 1.0. The answer seemed to lie with time-consuming spot welding operations. Careful observation of spot welding operations showed that there were variations in the time spent on fixing the work and spot welding positions. By devising a way of fixing the position according to the work, the time spent became consistent. The result of this was a 10-second reduction in the time spent on manual spot welding work, making it possible to create a one-operator U-line. A standard worksheet was prepared right away. This is the standard worksheet after the improvement was implemented. The creation of U-lines for the assembly process completed the flow linking the automated warehouse, FMS and the assembly line. The result? Smooth operation of an FMS line for sheet metal processing.
There were many excellent results from introducing FMS. We achieved our original aims of shortening the pre-delivery time and reducing the amount of goods being processed, but we have had other good results as well. One of them is a drastic increase in the rate of line operation, from around 10 hours a day before improvement to 18 after improvement. We also made improvements in terms of the number of operators. There used to be a total of 4 operators, 2 of them on night shift. Now, 2 operators can cover the 18 hours of operation, and the machines operate unattended at night. The yield rate on materials has also risen significantly, from around 65% to 85%.
What we've seen in action here is the kind of efforts which can turn zero setup operations into reality with the coordinated efforts of everyone involved. Success brings confidence, and at Orion Machinery, they now have complete confidence to move forward together towards further improvements in production and efficiency.